In this video, you will learn on how to solve and graph linear inequality in two unknown variables. Linear inequalities in two unknowns have solutions that are ordered pairs x and y. This ordered pair will make the linear inequality true. Here are the steps to determine the solution set and graph of linear inequalities in two variables. First is to change the inequality to linear equation. Then, determine the x and y intercepts and graph them on Cartesian plane. Lastly, change the linear equation back to linear inequality and use the origin test to determine the shaded area of the graph. The shaded area of the graph contains all the ordered pairs that will satisfy the inequality. For example, we have the inequality y is less than or equal to 2x minus 4. First is to change the inequality to an equation. So from less than or equal to, that will be changed to equal sign. So that is now y is equal to 2x minus 4. Then solve for y. In order to solve for y, we need to set value for x. So let x be equal to 0. So from the equation y is equal to 2x minus 4, change x with 0. So that is now y is equal to 2 times 0 minus 4. Then evaluate further, y now is equal to negative 4. So if x is 0, y is negative 4. Therefore, we have the ordered pair 0 and negative 4. Then, locate the point of the ordered pair on the Cartesian plane. So as you can see on our Cartesian plane, the point of the ordered pair 0 and negative 4 lies on the y-axis. Next is to solve for x. So in solving for x, we also need to set a value for y. Let y be equal to 0. So from the equation y is equal to 2x minus 4, change y with 0. Then that is now 0 is equal to 2x minus 4. Then subtract 2x on both sides of the equation. That is now negative 2x is equal to negative 4. Then solving now for x, divide both sides of the equation by negative 2. Then that is now x is equal to 2. So if y is equal to 0, x is 2. Therefore, we have the ordered pair 2 and 0. Then locate the point of the ordered pair on the Cartesian plane. So the ordered pair 2 and 0 is located on the x-axis. So we already have the 2 points. Now it's time for us to connect these 2 points. If the inequality is less than or equal to or greater than or equal to, then use a solid line. Since the inequality that we use is less than or equal to, then let us use a solid line in connecting the 2 points. So we already have our graph. Next is to apply the origin test. The origin test will be used to determine where the shaded region is. If the result is true, then shade the area where the origin lies. Otherwise, shade the other half plane not containing the origin. So the origin has the ordered pair 0 and 0. So that is the point of intersection of the x and y axis. So we have the inequality y is less than or equal to 2x minus 4. Let us change the values of x and y with 0 and 0. So that is now 0 is less than or equal to 2 times 0 minus 4. Then evaluate further. That is now 0 is less than or equal to negative 4. So our inequality is false. Since the origin test is false, then shade the area where the origin is not contained. So from our graph, we will shade the part where the origin is not included. The shaded area or region of the graph contains all the ordered pairs that will make the inequality true. It also includes all the values that will fall on the boundary line. Example 2, we have the inequality 2x plus y is greater than 4. First is to change the inequality into linear equation, that is 2x plus y is equal to 4. Then solve for y, let x is equal to 0. So that is now 2 times 0 plus y is equal to 4. Then y is equal to 4. If x is 0, y is 4. We have the ordered pair 0 and 4. Then plot the point of the ordered pair on the Cartesian plane. So the ordered pair 0 and 4 will lie on the y-axis. Next is to solve for x. So let y is equal to 0. From the equation, change y with 0. That is now 2x plus 0 is equal to 4. Then divide both sides of the equation by 2. That is x is equal to 2. If y is 0, x is 2. Then we have the ordered pair 2 and 0. Then locate the point on the Cartesian plane. The ordered pair 2 and 0 lies on the x-axis. Since the inequality symbol that we use is greater than, then we will use a dash boundary line. So the dash boundary line means that all the values that will fall on the dash boundary line is not included as a solution set of the inequality. Next is to conduct the origin test. So we have the ordered pair 0 and 0, and the inequality 2x plus y is greater than 4. Then that is now 2 times 0 plus 0 is greater than 4. 0 is greater than 4. The inequality is false. Since the inequality is false, then shade the area where the origin is not contained. So from our graph, as you can see, the shaded area is the area where the origin is not contained or it is not included. The shaded area or the region of the graph contains all the ordered pairs that will make the inequality true, but not the values on the dash boundary line. And last example, so we have two inequalities. X minus 3y is less than 6 and x plus 4y is less than or equal to 4. So first, let us have x minus 3y is less than 6. So we have to change the inequality into an equation, then solve for y, let x be equal to 0. That is now 0 minus 3y is equal to 6. Then that is negative 3y minus is equal to 6. Divide both sides of the equation by -3. So y now is equal to -2. So we have the ordered pair 0 and -2. Then graph it on the Cartesian plane. It will lie on the y-axis. Next is to solve for x. So let y is equal to 0. So x minus 3 times 0 is equal to 6. 3 times 0 is 0. So x now is equal to 6. If y is 0, x is 6. We have the ordered pair 6 and 0. Then locate the point on the Cartesian plane. It is located on the x-axis. Since the inequality that we use is less than, therefore, we will use a dash boundary line. So, all the values that will fall on the dash boundary line is not included as a solution set. Then, apply the origin test. So, substitute 0 on x and 0 to y. That is now 0 minus 3 times 0 is less than 6. Then evaluate further, 0 is less than 6. The inequality is true. Therefore, we will shade the area or the region where the origin is included or the origin is contained. So from our graph, as you can see, we shaded the area where the origin is included. So that is the graph of the first inequality. Next is to solve and graph for the second inequality. So we have the inequality x plus 4y is less than or equal to 4. So change into linear equation, that is x plus 4y is equal to 4. Then solve for y. Let x is equal to 0. That is now 0 plus 4y is equal to 4. Evaluate further, that is 4y is equal to 4. Divide both sides of the equation by 4. Y now is equal to 1. So we have the ordered pair 0 and 1. Then, locate the point on the Cartesian plane. So the ordered pair 0, 1 is located on the y-axis. Next is to solve for x. So let y is equal to 0. That is, x plus 4 times 0 is equal to 4. Then, x now is equal to 4. So we have the ordered pair 4 and 0. Then locate the point on the Cartesian plane. It is located on the x-axis. Since the inequality that we use is less than or equal to, then we will use a solid boundary line. Next is to determine the shaded area using the origin test. So we have the inequality x plus 4y is less than or equal to 4. So change x and y with 0. So that is now 0 plus 4 times 0 is less than or equal to 4. So that is 0 is less than or equal to 4. The inequality is true. Since the inequality is true, then shade the area where the origin is contained. As you can see from our graph, we have the blue lines. So we shaded the area where the origin is included. So from these two graphs of the two inequalities, the double shaded area or region from the graph contains all the ordered pairs that will satisfy both of the inequalities, including the solid boundary line but not on the dash line. That is solving and graphing linear inequalities into unknown variables. Thank you for watching, and I hope you have learned something.